Hi, and welcome to this brief introduction to the Number Systems Lab for EET 130, the 7-segment display. And I'll be talking about how to use the digital trainer box as well as a common anode 7-segment display for going ahead and implementing this lab. So here's a photograph of the 7-segment display that you'll be using for the lab. The actual chip that you use might be slightly different. There's a lot of different varieties to it, so don't panic if yours doesn't look exactly like this, but they'll have a great deal of similarities. And you'll see that the lab instructions show a slightly different kind of chip, but it has the same functionality. You can see that the chip shown in the lab report has these pins running down the side of it, and there's quite a few more pins than are actually used for the display, and are actually on that chip package. But like I said, there's lots of different ways that we can package the very commonly used 7-segment display. So here's that 7-segment display showing the labels that most people associate with each of the segments. So we usually begin with that very top light bulb, and we call that A, and then we go clockwise around the figure 8, A, B, C, D, E, F, and then the last one would be the G, which is the center bar of the figure 8. And then the decimal point is its own light bulb that can be turned on and off separately. The 7-segment display visual pinout diagram using a common cathode is shown here, and you can see different pins being lighting up different lights in red on this picture. It's just basically a visual way of seeing which pin lights up which light. But here's another one, and this is definitely the common anode. You can see that instead of being connecting to ground, the middle pin, both on the top and the bottom, are connected to VCC, or the positive voltage. So this is the image that you're going to need to refer to complete the lab if you're doing a common anode 7-segment display. So you'll be able to see which pin lights up which bulb, and that's how you'll be able to connect the diagram. So this is the pinout that I'm going to use for the rest of this video, and many of you will be using the same chip. The 7447 is a very common chip that we see again and again as a common circuit solution. You'll see that now the 7447 not only represents this chip itself, but also the circuit solution that can be used embedded within larger different circuits. And there's a number of pins as usual. Chips have that notch at the top and the circular engraved indicator of which is pin 1. And as usual, the chips, if you're looking at it from above, looking at that little circle, the numbered pins go clockwise, starting with 1 and going around through to 16. So this is the chip pinout that you're going to use for this lab, or I'm going to use for this video. If you do have a slightly different 7447 chip package, you may have a different diagram. You'll just use the diagram for the package that you're using. So this is the finished circuit. Boy, does it have a lot of wires. I've color-coded them, but you certainly don't have to color-code them. But you see that the digital trainer is supplying the power. It's also, we're using 4 of these flip switches at the very top of the digital. They're kind of silver switches. We're using 4 of them. We're also using some light bulbs, LED indicator lights at the very top of the breadboard. I'm sorry, at the top of the digital trainer, above the breadboard, just below the on-off switch. And then the breadboard itself containing the 7447 chip, the resistors that we need, and the 7-segment display. So we can use the switches and the LEDs in the digital trainer instead of using what is in your lab description, LEDs and DIP, dual inline switches that are mentioned in your lab. So the digital trainer already comes with them, but if you're not using a digital trainer, obviously if you're just using a breadboard, you'd have to make your own switches and go ahead and provide your own indicator LED lamps. So switches represent a 4-bit binary number, and here they're numbered 3210, most significant bit to least significant bit. And they're basically the 3, 2, 1, and 0 represent the power of 2 that they indicate in a 4-bit binary number. So if you can see here, switches 2 and 0 are flipped up, and switches 3 and 1 are flipped down. So there is no 2 to the third, and there is no 2 to the first power. But there is a 2 to the second power, which is 2 squared is 4. And there is a 2 to the 0 power. A 2 to the 0 is a 1. Any number to the 0 is a 1. So 4 plus 1 is 5. So this 4-bit binary number represents the number 5. 0101, or decimal 5. So here you can see that I've connected those switches to these LED lights, so I can see that the switches are working properly, and I've showing the number 0101. There's a couple of leading zeros. Obviously, I haven't even connected, so we'll just ignore them. We're only looking at the 4 bits. And it shows 0101. Notice here that the digital trainer has the resistors built in. We don't have to add resistors between the switch and the LEDs for these LEDs. And here it is on the circuit diagram. You can see that the lab circuit diagram has 330 ohm resistors connecting to those indicator bits, the least significant bit to most significant bit. We're going to use the switches that come with the digital trainer box, and we're going to use the LEDs that come with the digital trainer box. That lets us avoid this whole portion of the circuit that's X'd out. We don't have to recreate that if we're using a digital trainer. And you would need to recreate it if you're just using a breadboard. So the lab assignment also shows how the circuit is wired on a breadboard. And here on the right-hand side, I've put a square and an X in red around the parts that we won't be putting together, thanks to the fact that the digital trainer already provides these components. So it's very convenient and speeds up the building of the circuit. So we're going to connect this binary output. In addition to, you see the switches are both wired to the LEDs for indicators, but we need to also wire them to the 7447 chip. And they've got letters A, B, C, and D, capital letters on the pin diagram, showing how those switches need to be connected. And here's a zoom in of the A, B, C, D shown, and they're connected to the respective pins on the 7447 chip. So the output of the 7447 is going to drive the 7-segment display. So I've used orange wires here to show the connections for lowercase letters A, B, C, D, E, F, and G. And those lowercase letters, once again, are going to remind us of which of the light bulbs on the 7-segment display we're going to light up. Now here we do need to have 330 ohm resistors between the 7447 chip and the 7-segment display. Otherwise, you are going to burn out those lamps. It's not even a maybe. You know, even just touching it for a second directly to a power source is going to burn out those LEDs. So you'll end up with a 6-segment display instead of a 7-segment display, and your numbers are going to show up wrong, and you won't be able to complete the lab. Do not connect the 7-segment display directly to the power supply on the digital trainer or any other power supply. You've got to have the 330 ohm resistors between the LEDs on the 7-segment display and power. And you can see those here in your lab assignment, and I've circled them in green. Do not skip the use of any of those resistors. You'll also notice there's one extra resistor connecting the 7447 chip to the 5 volts source to go ahead and indicate a 1 or a 0 on different items. You definitely want to connect the resistors, that one resistor shown in the lab diagram. Do not skip the use of resistors. Did I mention that enough times already? Okay, hopefully you'll remember that you don't skip the resistors. So here's the lines leaving those resistors. I ran out of color-coded lines, so I apologize. They're not perfectly color matching, but in general, it doesn't matter how you color code your wires. It matters that you wire them correctly and that the circuit works. So you'll forgive the fact that they're not wired, but the wires are leaving the resistors, and they're coming to the 7-segment display at the appropriate inputs for the A, B, C, D, E, F, and G pins. We're not going to be using the decimal point in this lab, so you can see that the display correctly shows the number 5, which in binary was 0101, and it's showing it right here with the correct light bulbs lit up for the number 5. So the following photos demonstrate the function of the circuit. You can see here the switches are set to 0001, or the number 1. You can see the LED lights at the top are showing 0001, that the binary number 1 is indeed being provided electrically. And then at the bottom of the screen, you can see the 7-segment display correctly draws the picture of the number 1. Here's the number 2 with the second switch up and the first switch down there. So it's a binary 0010 with the number 2. 0011 is for 3. 0100 is for 4. 01015. 0110 is 6. 0111 is 7. 1000 is 8. 1009 is the, 1001 is the number 9. And finally, all zeros is the number 0. So you've got to demonstrate all of these, and also it shows that you know how to count in binary by using switches. You have to do all of those to be able to complete the lab. So hopefully that will shorten the amount of time you need to do the lab by seeing how someone else has done it. You go ahead and try it. I think you'll have a lot of fun with this one. And it definitely talks a lot to the ability of the electronics engineering technologist to really do hands-on in a system that doesn't just have a couple of wires, but really does have quite a few wires on it. And finally, I'm just going to leave on the screen here the 7447 and the 7-segment display chip pinouts. Those are the diagrams you need to finish the lab. And I'm looking forward to you getting started right away. All right, enjoy.